discuss the principle of inclusion-exclusion with two sets. In this video, we will discuss the principle of inclusion-exclusion as it applies to three sets. Let's start with the rule, and then we'll approach this from a different perspective. So for any finite sets, A, B, and C, the size of all of A, B, and C, A union B union C, is the size of set A plus the size of set B plus the size of set C minus A intersection B minus A intersection C minus B intersection C plus A intersection B intersection C. All right, so it can be easy at this point to become lost in the formulas. I mean, that looks crazy, but there is a really easy way of interpreting the principle of inclusion-exclusion using Venn diagrams so that we can avoid this tedious mess. So there's a conceptual way of understanding and interpreting this formula. All right, let's use Venn diagrams. So we have A, B, and C. Now, we want to figure out the size of A union B union C, which is the entire region here. Now, to do that, what we can do is we can count, and I'm going to try to use different colors here. We can count the size of A. And then we can count the size of B. And then we can count the size of C. All right, so it's a little bit hard to see this, but if we add the size of A plus the size of B plus the size of C, you're actually kind of counting a little bit too much potentially because A and B and C overlap. So for example, this region right here was counted multiple times. You can see some blue in this region and some purple, and right down here in the middle here, I see blue, purple, and orange. So that middle portion is actually counted 3 times. I didn't want to do that. I just want to count each region, each individual region exactly once to get the whole thing. So I double counted, and in some cases I triple counted. And if you notice in this region right here, I have orange and purple, and in this region right here, I have blue and orange. So there's some overlap. And so in order to compensate for this, we need to get rid of some of this overlap. We double counted, so let's take away some. So for example, this region that has blue, purple, this entire region right here, we're going to take away one of those. So we're going to take away A intersection B entirely. We're going to take only one of those away. And we'll say maybe the purple, it doesn't really matter, but that way we get rid of one of those colors in that region. And then we do that for each intersection. So we take away one of these regions, we take away one of these regions, and we take away one of these regions here. But there's a problem with that. If you notice, that middle region, we took away a total of 3 times. So that's not good. If we have A and B and C here, that middle region is counted 3 times, but then when we get rid of each of these intersections, that middle region is taken away 3 times. So we need to add back in that middle region, which is what this portion says right here, so that we can have every single individual region counted exactly once. And so that is how we can count A union B union C. That's a more conceptual approach to understanding this giant formula. And you can actually do the same thing with A intersection B, or A union B union C union D. You could do the same concept with 4 subsets, 5 subsets, and so on. There is a conceptual way of approaching this. Anyways, thanks so much, and I'll see you in the next video.